Okay, welcome to CSR. Today we're talking with Dr. Neil deGrasse Tyson, one of the most accomplished astrophysicists and science communicators. So first I want to talk to you about your latest book, Welcome to the Universe, Pocket-Sized Story. Came out this month, September 6th.
A brief welcome to the universe.
Yeah, a brief. It's the pocket-style edition of the New York Times bestseller. So what was the inspiration for the book, and what was the co-writing process like?
Yeah, so that book has quite a bit of DNA behind it. My two co-authors were fellow faculty at Princeton when we co-taught a class, an introductory class in modern astrophysics. This is some years ago, and the course started. It was a new course in the curriculum, and so it started out with about 30 people in it, and after a year and a half or 2 years, it was up to like 300, and we have to keep moving to bigger and bigger classrooms. So we were delighted by the reaction. There were three of us who taught it. We split the universe into sort of Earth and the solar system, and then stars and galaxies, and then cosmology. And I took the first part. One of my colleagues, Michael Strauss, took the second part, and Rich Gott took the third part. And after that, we figured, this is worthy of a textbook, but not in the traditional sense of a textbook, because textbooks are really, when you think about it, they're kind of one long run-on wiki page, right? It's very informational, but they're not necessarily fun to read. So we created a textbook that we thought you might just like to read, but it was a big fat book. It had all the information in the entire course. Then we realized there's some people who just want a taste of what might have happened in that Princeton class. And so we culled and we cherry picked and got all the coolest information you would have learned in that Princeton class and put that in a brief welcome to the universe. And I can say something even more. I can say what's in that book might be all you would have remembered from the class. How often do we remember? You don't remember everything from all the classes you took. You might know it for the final exam, but every month that unfolds thereafter, bits and pieces drift away, they evaporate. Then you can ask, well, what's left? So this book is kind of what would be left years later after you had taken that class.
Yeah, and now a general question about astrophysics in general. What are the most interesting advances in the field of astrophysics right now?
Oh, there's tons of frontiers. What I like especially is the effort to try to find life in our own backyard, in our own solar system. And that would include Mars. Well, there's no water on the Martian surface, but we have really good evidence of water that had seeped down from long ago when Mars once did have water that is seeped down into kind of a permafrost, but there might be pockets where it can melt. And everything we know about life on Earth tells us that it thrives in liquid water. So one of NASA's mission objectives is to follow the water. And there are many other places in the solar system that has water, including some of the moons of Jupiter. And so the search for life of any kind, microbial would be just fine, in our own backyard is one of the more exciting endeavors. And that combines not only the theoretical expectations with the experiments of actually sending probes there. And we end up collaborating with geologists as well as biologists in order to answer those questions. But also, we still don't know what dark matter is, even if it is matter, but we know it has gravity. We don't know what dark energy is. We can measure it. It's acting opposite the wishes of gravity to force an acceleration in the expansion of the universe. We don't know what's causing that. Another one is we don't know, I guess this would be a biological frontier, but it affects the search for life in the universe. We don't know how Earth went from organic molecules to self-replicating life. That transition is still a bit of a mystery in the lab, but we've got top people working on it. And one last one is, will we ever reconcile general relativity, Einstein's general relativity, with quantum physics? Quantum physics is the most successful theory of our understanding of the universe we've ever put forth. It's never been shown to be wrong in any prediction that it has ever made. We know there's a limit to general relativity. It can't understand what happens in singularities, like the very center of a black hole or the very beginning of the universe. It's like dividing by zero. You might remember from math class that the equation blows up. So we know there are limits to how much that of the actual universe that applies. So will quantum physics one day absorb general relativity in one understanding, or is there a third umbrella waiting to be hoisted that will then enclose both of those? And if you're a betting person, I'd bet that there's a deeper third account of the universe that would to bring it all in terms of one coherent understanding of how the whole universe works. But so those are the top four, I would say.
Another question about space in general. You've talked about terraforming other planets to fit human habitats many times before. But what are your thoughts on engineering the human body using CRISPR and other technologies to fit living on other planets, like vice versa?
Yeah, there's a lot of talk about that. And in almost every case, it's just easier to introduce an engineering solution to the problem. And I'll give an example. This is from the 1940s and 50s, I think, where planes are getting faster. Airplanes, we broke the sound barrier, and it's not good enough to just be fast. In the military, you also want to be able to maneuver. And if you were moving fast and you maneuver, you introduce G-forces within the cabin on the pilot. And if they're pulling out of a turn, for example, then there are G-forces that where the blood leaves their head and goes down to their lower extremities. And so at the time there was talk, do we give them some kind of drugs that will reduce their brain's dependence on oxygen for this brief amount of time? They were thinking of these biological solutions, and the engineers said, let's just create a pressure suit, or there are these suits that squeeze in your lower extremities when these high G forces are kicking in, preventing the blood from ever getting there in the first place. So your blood can't leave your brain if it has no place to go. That was a simple solution. It didn't involve chemically changing the human body. And take, for example, the concern about loss of bone mass in long-term zero-G environments, such as you might experience in a long-term space flight. Do we re-engineer human physiology to not lose the bone mass? Or do we just spin up the spacecraft, and so you have artificial gravity that removes the problem entirely? So the history of this exercise has tended to be one of engineering solutions to what might otherwise be thought of as a biological need. So given that track record, I'd be looking forward with that expectation on how engineers can help us out. Just throw another one in there, the high radiation flux from the sun and the solar wind, which makes it dangerous to leave our protective magnetic blanket here on Earth. You might say, well, let's re-engineer us to be resistant to high radiation, or you build a radiation shield and then you're fine. All right, so that's how I think about it going forward. And I base that entirely on the successes of the past.
Another question about space exploration. You've previously said that the biggest issues with rockets is their unreusability. But with, for example, SpaceX testing and developing reusable rocket designs, what do you think the implications are for that?
Well, it's entirely cost, right? If you fly to Europe in a Boeing 747 or 777, you don't get off the plane and then they discard the plane and roll out a new one. They reuse it. So the reusability, it's two-pronged. It's the reusability of the parts plus how quickly you can reuse the parts that factor into the per mission cost that you encounter. And all the billionaires going into space have been putting great effort into reusability as well as the rapid return to keep those costs down. Because if you see it as the future of it as a tourist attraction, you want as many people who can afford it as possible. And so, yeah, it's a fundamental to making all of this work.
Question about Europa, one of Saturn's moons. So it has an 80-kilometer deep ocean covered by a 10-kilometer thick ice sheet.
Europa is a Jupiter moon, not a Saturn. Titan is. You said Saturn, I thought you said.
Sorry.
Yeah.
But Europa is outside the sun's habitable Goldilocks zone. So how did it get warm enough to have such an extensive ocean?
Yeah, so when we started looking and thinking how we would look for life, we're looking for life as we know it. So look for life in an Earth-like planet around a sun-like star, orbiting at the right distance to sustain liquid water, because we need liquid water. And it turned out to be very needlessly restrictive, because it assumes that the sun is the only source of energy. And turns out, if you are a moon in orbit around Jupiter, there are forces operating on you that will dissipate into your physical body and deposit heat there. And so these are the tidal forces. So the moons of Jupiter, their orbits are not perfect circles, yet they're tidally locked to Jupiter. The consequence of this is their shape is always readjusting to align with Jupiter's sort of gravity vectors. But because it's not a perfectly circular orbit, it's always sort of jiggling back and forth, and the jiggling back and forth is stress on the physical body, and that stress gets pumped into the moon in the form of heat. And it's not fundamentally different if you've ever played a racket sports like squash or racquetball. When they say, well, let's warm up the ball for a few minutes before you begin, that is a literal thing that they're doing, right? They hit the ball compresses, and the ball then restores back to its shape because of what the properties of the rubber, and you just keep doing this. And every time you distort it and it pumps back into shape, you are infusing it with just a little bit more energy each time until the ball physically warms up. That's what's happening to Europa and other moons around the solar system, including Io, which is the most volcanically active place in the entire solar system, and sort of other moons that are nearby their host planets.
Interesting. So, some questions about science communication. Why is there such a big mistrust in science these days, and how can we formulate a more scientifically literate society?
Yeah, that's a great question. I wish I knew. Maybe you'll figure it out. I have a guess. My guess is science is so successful, people just take it for granted. You know, there's a apocryphal comment on this where someone says, why do I need a space program? You know, I've got, the Weather Channel and I got maps on my thing. What do I need the space program? And everything they list involves the space program. So maybe science and engineering and technology needs public service announcements. Maybe they need an advertising campaign to alert people of all the things in your life that are enabled and empowered by innovations in science and technology, without which, we damn near would be living in the caves. And so just consider, there's a movie from 1987, many people have seen it, called Wall Street. And Gecko is the Wall Street trader who's ruthless and he's wealthy. In 1987, and there's a scene where there's a party at his beach house, and he's on the phone walking on the beach. In 1987, he said, "Wow, you can do that? You don't have to go to a phone booth?" And the phone is just like a shoulder-mounted cell phone. And I remember thinking how cool that was. And now I look at that and I was like, ew, I don't want any of that. And so So technology and science moves at a pace, and we just absorb those benefits that it brings to society without even thinking of what it took to get there in the first place and what it takes to sustain it. So for someone to just say, I don't trust science, when they may actually be alive today because of science, it's a failure of the system to market itself. That's a guess that I have about how we might fix this. But if it's not that, I don't know what it is.
Do you think the educational system has anything to do with it?
Yes. So thank you. So if you go back deep into the curricula, the kindergarten through 12th grade curricula, what we surely need more of is sort of internet wisdom. Okay. So you're not taken advantage of by charlatans on the internet, having you believe anything they show you. So a certain healthy internet skepticism, combination of wisdom and skepticism there, but also people need to know what science is and how and why it works. It's not just, oh, learn this in the book, get tested on it, and then move forward. No, it's, yeah, sure, learn what's in the book, but learn why that's true and how we came to recognize that it's true and why it is that the methods and tools of science are better than anything anyone has put forth at gaining access to what is objectively true in the physical world, in the natural world. So, yeah, it's I would say if science were taught that way, then when you hear a new scientific result, you'll know how to receive it, right? Because you'll hear a result this week, and then in a month, you'll hear an opposite result. And nowhere in there did you realize that the press reported on one research paper, not on an emergent consensus. And if you're going to chase single research papers, you are susceptible to not converging on one truth because the research papers are on the bleeding edge of anybody's understanding of anything. That is the process of science. And then when the papers coalesce and surround one result, then you could say science has a new result to report. But everybody wants to be the first to report on it and get that first research paper. And it leaves the public a little confused, I think. So the press are partly to blame here, I think.
Some people think that one day we will have uncovered all there is to know about the universe. Others think that because of this scientific process, we'll never run out of questions to ask. Where do you stand on this?
I don't know who's saying that one day we'll discover everything. My favorite adage there is, as the area of our knowledge grows, so too does the perimeter of our ignorance. And so there's just no sign that things will ever end, especially since the dark matter and dark energy that I spoke of earlier represents 95% of what is driving the universe. So 95% of what is driving the universe, we are clueless about what it is. So to say, oh, we're on top of the situation, it doesn't really look that way. So for me, I see it going on for the foreseeable future, perhaps forever.
So what was your main reason for getting into physics, like the field of physics personally?
Oh, no, I just enjoyed it. Well, I enjoyed the universe primarily. And then I realized to commune with the cosmos, I needed some fluency in math and physics because those are foundational to anything else that's going on. So, and that curiosity and that wonder, that love was established as early as age 9. That's when I first realized it. And then by the time I was 11, it was like I was done. I was like ready, ready to be an astrophysicist.
And what caused you to shift your career from career in academia to science communication?
Oh, no. So to me, the science communication is I do it because it's asked of me. Part of it, I do it because I think I can make a unique contribution, like my podcast, Star Talk. I think the combination of everything that I am works possibly uniquely in that role, interacting with a comedian, with celebrities, with other scientists, with that world that we've created. I think serves my talents very well. I have a possibly delusional dream state where enough other people come onto this landscape doing podcasts and bringing science to the public that I can just slowly back away and exit the back door and just go to the Bahamas and let everybody else take it, and then resume my active research career. So right now I'm doing this because I can, and it's opportunistic, but I'd be delighted to get back into the lab.
Yeah. And ask some questions we got from people online.
Mm-hmm.
The first one is, how has politics affected scientific progress in the past decades?
So politics, that's a great question, by the way. And so politics it doesn't determine what is true. The political influence on the funding of science does not determine what is true, but it can determine what branches of science get more fleshed out than others. So if you care about the science of war and you fund it as such, then science will be producing weapons. And in the limit, weapons of mass destruction or weapons of some other kind of destruction yet to be imagined. So if you decide, well, I care about the green movement, you want to invest that way, we could make great headways in battery storage or in solar panels or in hydro or in tidal driven energy. So what kind of government gets elected will influence what kind of science gets funded, but ideally it would have no effect on what gets found, what results people find. And so yes, as scientists we are at the beck and call. No, we're at the mercy of funding agencies.
Someone else asks, since the universe is expanding, what is it expanding into?
Oh yeah, we have no idea. That's my answer. There's no reason to presume that space and time exist only in the dimensions that we experience. We have 3 spatial dimensions, 1 time dimension. But imagine more spatial dimensions. Then you could have an infinite number of universes that are each infinite, that do not overlap each other. And that sounds crazy, but it's not. If we use a lower dimension example, just to get some kind of grasp on this, imagine a flat sheet of paper, and it's 2 dimensions. It has sort of length and width, but no depth. Okay, so there's a sheet of paper, and we're all living in that sheet of paper. That's our universe. And let's say the sheet of paper goes off to infinity. Well, imagine another sheet of paper just sitting 1 millimeter above that. It could also go off to infinity. So you have 2 infinite universes that are getting packed together in a higher dimensional space. So if we're expanding, there's no reason to think it's not just doing so in a higher dimensional manifold, if you will. But so it would be interesting if we one day collided with another galaxy. What would that even look like? We have people thinking about that, feeling the presence of a parallel universe within our own. But there's nothing conclusive on that yet.
It's another one of the big advances in astrophysics these days, right?
Yeah, definitely. Well, the multiverse is a frontier. Yes.
Another question someone asks is, what are your thoughts on the unscientific wave that is permeating society? We have people rationalizing their own conclusions about everything, from COVID-19 to climate change. Where have we collectively failed as a society to teach basic science and empirical thinking?
Well, yeah, we want to encourage people to arrive at to think for yourself and to don't let someone else do your thinking for you. We encourage that. But there's a limit to that. So for example, suppose someone comes up to you who has studied a problem for 10 years and you've studied it by visiting some wiki pages for 10 minutes, and then you have a strong opinion based on what you have discovered. Then are you going to usurp the opinion of this expert who's speaking to you based on what you have found? That would be unwise, because you need to recognize that what an expert is. An expert is someone who probably knows more about something than you do. And so you need to value that in some kind of way in your decision making. Nothing wrong with retaining some level of skepticism, but for you to think that after a few minutes on a wiki page, you have competitively true information to someone who has devoted their career to that same information, that's just delusional. And so maybe what we need is training to understand when you actually understand something and when you don't. That would be highly useful as an added curriculum item in K through 12.
And what do you think is the role of social media and the internet in this?
Yeah, I mean, I think we're still in our infancy. I mean, consider that after the printing press was invented, movable type, in the 1430s, 1440s, it was 150 years, some long stretch of time before someone figured out maybe we could print newspapers and give people news of the day or of the week. That we had to figure out that was something you could do with that device. With the internet, it is such in its infancy. I think we don't know what to do with it. We're not wise yet. It's still just this free-for-all playground, and people get hurt. People, people tribalize. There are things that happen that I don't think people predicted for it. None of which is good. I mean, much of which is not good, and not good for the stability of civilization. So, but I have to believe, based on no evidence, that there's more value to people communicating with each other than not.
Yeah.
And maybe the internet will become the ultimate communication device that brings us together rather than divides us.
If someone else asks, why is there something rather than nothing in the universe?
Well, the universe is mostly empty, so maybe you should be asking why. How come there's anything at all amid the nothing? The universe is mostly empty space. So that question is a people think that's a cool, deep question, but it really isn't. Most of an atom is empty space. Most of space is empty space. So you can ask, why are there these atoms in space rather than nothing in space? But to say, why is there something rather than nothing? There is nothing, okay? There's a whole lot of nothing out there. So I just want to put that to rest. Now, why is there matter? We know what happened in the early universe. The energy, which normally becomes matter and back to energy symmetrically, according to E equals mc squared. So if you have a high energy photon, it can spontaneously become two particles that stream away in opposite directions. And they're identical particles, but they're opposite. One is matter, one is antimatter, but they're otherwise identical. And then if they come back together, they make light once again. Okay. So for reasons that are mysterious to this day, there's an asymmetry in the conversion of light into particles and particles back into light. There was slightly more matter particles made than antimatter particles. 1 out of every 100 million photons of light split asymmetrically. And so all the other matter, antimatter particles annihilated, giving us light, leaving behind the 1 in 100 million photons that became regular matter. And so had that been a perfect match, there would be no matter in the universe at all. It would just be a volume of light. And that's it. And for all we know, there are other universes for which that's true. be a very boring, uninteresting universe. But that would be it. Now, if you want to still think of light as something rather than nothing, then that's the reason why there's the something.
Yeah. So the last question is, what is your biggest source of inspiration?
Oh, I like looking at the achievements of others. There are people who prefer to stay in their family lineage, and they'll say, oh, my uncle was an engineer, or my aunt was an attorney or medical doctor, so I'm going to be one of those. And I'm thinking, really? You're restricting what you want to be in life to your recent ancestors? How about your more distant ancestors? How about your human family that extends across 7 billion people? We're all related. And so, well, not family. Well, how are you defining family? Only 2 generations back? Go back a few more generations and your family is a whole lot larger. Go back 10 generations and you have hundreds of thousands of people who you would count as part of your family. You go back 30, 50 generations as millions of people. So when I look around and I see someone do something brilliant, an artist, a scientist, a musician, an athlete, and I say, we all have a little bit of that DNA in us. So maybe we can achieve according to our dreams as well. So that's how I think about it.
Thanks so much for being with us today.
Oh, excellent. Very happy to serve.